Hello and welcome. Today we're going to be taking a look at the 1 billion row challenge, which is something that's like designed or I guess intended for Java. But since Java is a horrible language, we're going to be using Rust. So the premise of the 1 billion row challenge is that you have a billion rows of input data. I don't know if they have an example on here. There's a lot of files in this repo at the top level, in case you can't tell. Yeah, I guess there's an actual example here. You've got a billion rows, which are pretty straightforward. It's just the city name, a semicolon, and then like a temperature, and then a new line to get to the next row. That's it. Very simple input data. And then the expected output is also very simple. You take the city name and you provide the minimum, the mean, and the maximum. Like the minimum temperature, the average temperature, and the maximum temperature from the input data. That's it. So ultimately, it's very straightforward. The biggest aspect of it is that there are 1 billion rows. Yeah, so this was a fairly sizable challenge. I think it was a couple of years ago now. Submit your implementations by January 31, 2024. So yeah, like 2 years ago now. Where people would implement this in Java and submit their implementations. So you see that it gets down to, what is this, minute, second, millisecond. So that gets down to about 1.5 milliseconds for just like the standard input data. And then there's a couple of different versions. So there's, I don't know how many of the top there is. Does it say? No, it just says results. So some number of submissions. And then there's another like category called like bonus results, which is running on more cores, with more threads, running with 10k keys, so like 10,000 different city types or city names. Yeah, and that's it. But yeah, let's go find the rules. This is a really tall page, which is annoying, but that's fine. So this is just some Java stuff for building it, some profiling stuff. Okay, the rules. So this is not going to really apply to us because it's just for Java, like which Java runtime you're allowed to use and that kind of thing. No external libraries. Yeah, we're not going to use external libraries. Implementation must be a single file. This is, I guess, I would assume this is more so just for the aspect of being able to submit it, and to keep like the repo relatively organized, but I guess we can follow this. It doesn't really matter. Computation must happen at runtime. We can't just have like a build.rs to post or to just like paste a string. That'd be funny though. Input value are as follows. Yeah, so this is super important. So the station name is a UTF-8 string between 1 and 100 bytes, without a semicolon or a new line. And then temperature value is a non-null double between -99 and 99. Okay, always with one fractional digit. And then there's a there's a maximum of 10,000 unique station names. That shouldn't ultimately matter much for our solution. Excuse me. But it could. So we'll see about that. Line endings in the file are new line, or just like the single what is that, line feed, and not like a carriage return like on Windows. Implementation must not rely on specifics of the dataset. Yeah, that's fine. And then rounding of output values must be done using the semantics of IEEE 754 rounding direction round towards positive. So that is something that we'll probably also have to look out for. And then I think this is the only part that actually applies to us. I do have this repo cloned locally so that we can run like one of their examples to see what it's like on this platform. Oh, I forgot to time it. So here you can see the output. I don't know if bitrate is going to be good with that, but the output is literally just key equals, then min, mean, max. But if we time this solution takes about 800 milliseconds. I mean, it varies a lot. Let's, you know what? Let's hyperfine this. Hyperfine. In fact, I think I was reading through here and it says somewhere that they use hyperfine on here for evaluating the results or something. Hyperfine. Yeah, it's somewhere. Yeah, and you see there's a separate script for every single submission. Oh, it's literally right here. I missed it. But yeah. And so if we look at this, it took about 750 milliseconds. Sure, great. Yeah, so let's get started. I have the measurements.txt in here. You can see it's 14 gigabytes. If we look at that file, you can see it is literally just as it describes. It's city name, semicolon, and then the temperature. Took about 3 minutes to generate, so I decided to do that ahead of time. But yeah, so let's start with like a super naive implementation. So let's first of all just open the file. Measurements.txt. And there's no reason we actually have to handle errors properly, so let's just unwrap. Do that. And then let's also say buff reader. Run on file. And then if we go over the lines of the file, then we can just line, split on semicolon, or I guess split once. Oh, and line is an error, or can be an error, so let's unwrap that. Unwrap. And then here, what? So now we get the station, and we get the temperature. And we can unwrap this as well, because we know that there's supposed to be a semicolon. Then station is a string, temperature is a string. So we can say let temp is temp.parse as a double dot unwrap. And then now we need a way to keep the data. So let's have a map is a hash map. And then let's create a struct because we're super cool developers. And let's call this, I don't know, station. And we're going to have a min, which is an F64, a max, which is also an F64, a sum, and the count. And then now we're going to say if let's s is map.getMute s. Actually, no, you know what? Let's use the entry API. So map.entry. We're gonna have to use line or not line, but station to string, which is gonna be a little bit annoying, but that's a place where we can do an optimization. And or default. We can derive default on that. Or no, we have to impl default for station. Because we can't do default, otherwise we're gonna get like 0, or I guess yeah, I guess if we get 0 for min, then it's gonna be wrong. So min needs to be F64 max, and max needs to be F64 min. Everything else can be default. And then we can also, and no, actually, wait, can we do impl add assign with right hand side being an F64 for station. And then all we say is self.min equals self.min RHS. Self max is self max RHS. Sum plus equals RHS. And then self count plus equals 1. We'll use some of the fancy Rust features for this because we can. Okay, so we get a station, and then all we're gonna do is plus equals. What is the issue here? Binary assignment operation plus equals cannot be applied to mute underscore. Right, we need a type here. So I don't care about that type, but this is gonna be a station. I need to be a star. Okay. Very, very nice. Great. So that should get us the running total, like the running sum and like min and max. And then we need to print it using their special format. Let's go look at here. This is such a tall page. All right, I guess, okay, we can look at it in here. So it's gonna be key, or like the station name equals, and then the minimum, the mean, and the max. But it needs to be sorted in alphabetical order. So let's, for now, just do map dot into iter dot. We can't sort on this, but we can collect into a vec. And this is going to be stations, and then we can say stations dot sort unstable by key, and this will take like the station name and the stats and sort by S. Right, S is the string. Return of closure. Cannot mutate immutable variable stations. Oh, well that needs to be that, obviously. What does this do? Why are you having weird lifetimes? Can I do X and then X dot 0? I don't want to clone this. Sort unstable by A B A dot comp B. Like that. So that way we just basically manually do the sort by key. Okay. Now if we do for the station, the name and the let's actually rename this to stats, I think. So now we can do for station and stats in stations, or not in stations, in stations, but like that. Then we can do print open curly, print close curly, and then here we're going to say if we need to enumerate into iter.enumerate. If I is greater than 0, then we're going to print the comma. This is my preferred way to do like comma separated. You could do also like get the length and then check if we're not at the end and then print the comma at the end. But I find that this is the cleanest solution. And then we're going to say print the station, then the min, the mean, the max. So station and stats dot min, stats, well, let's add a mean method, why not? And stats dot max. And then here, let's impl stats and have a function mean, which takes self and returns an F64. And we can even, let's derive, clone, and copy. So here we're gonna say self dot sum divide by count as F64. Yeah, self.count. Great. Now if we run this, actually we might as well go directly into release mode. I predict this will take probably like a minute. Oh, I should probably time it too. Time. So yeah, this will take a little bit of time. Like the Java solution that took, what was it, 750 milliseconds? I don't think we'll be able to achieve that same amount of time. I suspect that the people or person who made that solution spent a very, very, very long amount of time on it, like the order of weeks or something like that. And even in Rust, which is a compiled language and has the ability to have so much better performance than Java, doesn't really come close just out of the box to spending a very large amount of time on performance improvements. So we'll see how much this super naive solution is going to take. And like, obviously this is a very, very naive approach. I think while that's running, on here, there's, he mentions that there's a naive implementation that took like 3 minutes in the Java version. Let's see. Yeah, so this is like the naive approach, which is effectively what we're doing right now. Yeah, pretty much. Yeah, this is almost exactly what we're doing. It's just more Java-y. And on here, yeah, it takes 5 minutes on their like, yeah, not quite standardized hardware, but like the more uniform hardware. Yeah, okay, so our solution took 66 seconds, which is not bad. Like, just out of the box, it's faster than the Java one by an order of like 5 almost. So that's pretty good. But let's see what kind of improvements we can make. So first and foremost, this hash map, we have to frequently reallocate it. So let's just try with capacity and set the capacity to start off at 10,000. Like, we know that we're not going to have any more than 10,000. Let's do that. We know we're not going to have any more than 10,000 names, like station names. So we can just kind of default with that much memory. And I don't really expect this to save much time. We're trying to beat 66 seconds here. But I guess let's find out. And I guess while that's running, we can look and see if there's anything else that immediately stands out. So another thing is right now we're doing lines by, like, we're using the buff reader lines method, which like parses strings and stuff. We could just replace that with like bytes and split on the like new line byte, so that we don't actually care about UTF-8. It does say in the rules, yeah, this, it does say that the names are UTF-8 strings. But as far as I understand, with UTF-8 strings, sorting is literally just a standard memory sort, and then the actual, okay, so that saved for about 4 seconds, but the actual main loop here doesn't care about the UTF-8 encoding, or like the fact that they're strings, so we could just do byte slices. But what I want to do before we do any of that is tackle this. So right now we are reading the file. In fact, I think, I honestly never remember what like user time versus system time is in here, but I suspect we spend a large amount of time waiting for data. So like reading from the file from disk or SSD or whatever. I suspect that takes a long amount of time. So there is a feature on Linux called mmap, which is for memory mapping, which takes a file from the operating system and takes a file from the file system and maps it on the in memory. So this is a C function where you pass in some pointer if you have like a target, but we'll do null for that. And more importantly is the file descriptor. And then it returns a pointer that you can just use to read content from the file. And so we're going to use this. So normally in Rust, there's a crate called memmap. Is that what it's called? Yes. Which gives you this mmap struct that you can like build stuff, but we're not using external dependencies. So there's also libc, which is, we could arguably depend on it because it's already used by the compiler. Or like the standard library already uses libc. It just doesn't expose that to us. So adding libc is free, but that's still adding a dependency. And the thing is, since we already depend on libc, not necessarily the crate, but since we depend on libc as in the library, the C standard library, if we look at the mmap, the mmap call, we can literally just copy this. And since like if we look at the source of it, it is literally just an external declaration for like the linker. We can do the same thing. We can say mod libc, then extern c. You have to do unsafe now, and just put that there. Consider importing this type alias. Yeah, so we have we can import some stuff. So FFI, this doesn't exist. FFI, and then this doesn't exist. These are both part of. Oh wait, does this exist? Oh no, yeah. So it's deprecated. It says to use libc crate. So those are both type aliases provided by libc, and we can just go look at them. So size t is just a usize. So usize, and then offset t or off t is just an i64. I64. And now we have this mmap function from the libc crate without doing any implementation or anything. So it's a little bit hacky. It's not great, but since we're not doing any dependencies, we kind of have to do this. Okay, so now I want to create a function called mmap, which takes in a file and it returns a static U8. The lifetime here is not technically static. It really just lives until we unmap. But like, we don't really need to unmap. I think it's fine to just leave it like this. Like the proper Rust way would be to create a separate type that just dereferences into slice. In fact, I'm sure that's what mmap does. Or this guy. I'm sure it just returns an mmap. Wait, hub unsafe map. Yeah, so it returns an mmap that probably has a. Oh, it doesn't implement drop. That's interesting. I would have expected it to implement drop and then on drop it would unmap, but it does not seem to do that. That's kind of surprising, actually. But okay. There's another system call called or not system call, but libc called munmap. Yeah, which is for saying, hey, kernel, I'm no longer using this, but we're gonna be good C developers and not do that. Okay, so mmap. We don't really need to pull this up anymore, but yeah. So in here, what are we gonna do? So first of all, we need to get the length of the file. So len is gonna be file, metadata, unwrap, because again, we don't care about handling errors properly, and then just len, yeah. So that gives us the length of the file as u64. And then we can say libc mmap. So the address here is if we have like a destination that we want to map it to. So if we look here, I think it will talk about the arguments somewhere. This is the man page for the mmap function. It says it somewhere, but I don't feel like digging through it. So the address that we want to map it to, or if we don't have like a destination, then we can pass in what am I saying? Standard pointer null mute, like that. And then the length is going to be the length and prot. So protection flags are something you can see right here, which basically kind of describe how we intend to use this data. And so we want prot read because we're just reading. And we can look up what that actual value is here. So libc prot read, and then we'll just literally copy this declaration and dump it into our really bad libc. So then here we can say prot read, and then flags here, I think is the next section, which is basically some like exposure data, I guess, like for how like how it interacts with other things. It's a little bit unclear to me. I haven't used mmap all that much, but we're basically gonna use private map private. So this guy, and we can also just dump that in our libc. Read with the Wayne's World guy plays villain voice. Isn't that maybe I'm thinking of the wrong thing. Isn't that like Mike Myers? And then we have map private. And then we can say file. How do we get the file descriptor? It's as raw FD. And then offset is the offset from the beginning of the file that we want to map, which we can just say as 0. Okay. Mismatch typed. Right, so now we have a pointer. Oh, and this function is unsafe, by the way. Function arguments to this are correct. Right, so length is supposed to be a U size. And what's our safety on this? So, I mean, there's not really any... I don't know what the requirements around mmap are. So we're just going to say safety. I said so. Said so. Okay, now we have a pointer, which is a pointer to the void. Goldmember was the Bond spoof. Yeah, I don't know that I've actually seen Wayne's World at all. Thinking about it. Maybe I'll have to watch that at some point. So now we just have a pointer, which is great. From this, we can say standard slice from raw parts. Pass in the pointer. We know the length, and so we can just do that. This needs to be unsafe. And this one we actually have a safety, which is mmap returns a valid pointer. And I think we can say also, like, I think the pointer here can be null. Null. Why are you highlighting everything? This is the only reference to null. Function is blah, blah, blah. Let system choose an address specifying null. Right, so this is for the, this is for the, like, the first argument, which is like the destination address. I'm surprised that there's nothing for return value being null. Upon successful completion, mmap function shall return the address. Otherwise, it should return a value of map failed and set error no. Okay, so we can do, let's just assert pointer not equal map failed, which is this one. Oh. This is interesting. Why is it an underscore? Not zero as mute C void. Okay. That's what Jay Blow is quoting when he says Cornholio in his stream titles, by the way. I actually haven't looked at any of like John Blow's stream stuff. I've seen him referenced, but I've never actually managed to check out a stream. I think the only time that I've actually seen him streaming is when I was just I wasn't actually watching streams. I was just like it somehow showed up. I think what was that? I think I had this like the stream page open or something, and I passed by it, but I wasn't able to watch it at the time. I want to watch one of his streams. He seems like an interesting guy, and like the Jai language is interesting. That was the worst way I could explain anything, but that's fine. It's too early for streaming. Okay. We can just assert that we're not map failed because it's fine. I hardly ever watch until he tried to play Lean Lang as a game. Lean is the like proof thing. Play Lean Lang as a game. That sounds interesting. Anyways, so from raw parts takes the pointer, which is a mute C void, but we need it as const u8, and then the length needs to be a U size, which I guess we can say as U size here. And now we don't need to do this everywhere else. So now we're technically doing it. However, there's one other thing called advise, yeah, which is basically taking this memory map and giving a hint, or I guess advising the kernel for how we intend to use this. And the most important aspect of this is adv sequential, which basically says we're going to be walking this memory map and reading stuff in order, which is what we're doing. We're reading line by line, sequentially. So we're going to call this function. Let's go back to the libc and say, what is it called? It's called advise this guy. And then let's copy this source. And we're going to paste that right there. And this is going to be U size. Cool. So now we can do this advice. Let's see. So here we're going to say libc advise. The address is the pointer that it returns, that the mmap returns. The length is the length, and advise is going to be adv sequential. So we can just grab that here. Adv sequential. Sure, let's take a look at this. Ooh. Translate from German. Is it in German? No, it's literally, oh, wait, it's got some German. A repository of learning games for the proof assistant Lean. Natural number game. What the hell is this? Welcome to the natural number game, an introduction to mathematical proof. In this game, we'll be building a basic theory. Yeah, okay, I'll check this out. This would be interesting to do on stream, or interesting to look at on stream at least. Let me add this to my stream ideas. Yeah, I'm using Alacrity for my terminal, or for my terminal emulator. And then I have, hold on, let me. There. I'm using Alacrity for the terminal emulator. I'm using i3 for my window manager. Probably should switch to like Wayland or Sway or something, or Wayland with Sway, or so people keep telling me. Using a plexer. I don't know what plexer, what you mean by plexer. I mean, I use tmux for like terminal multiplexing, if that's what you mean. But yeah, actually all of my configs are available publicly. Configs. Yeah, I'm using tmux. Okay, so advise pointer length, and then the advise here is libc adv. Oh, did I not copy that over? I got distracted. Adv sequential. This feels so like just cursed to just be copying code from libc, from the libc crate, but it's fine. Adv sequential. And this is unsafe, obviously, because it's a system call. And safety, the pointer is from mmap. That's pretty much the only thing we need to do here. And then what do we return? We return an integer, which is just ret. And then if, what's the return value here? Return. On success, it returns 0. On error, it returns -1. I'm not even going to bother with, like, printing error messages or anything. I'm literally just going to do this. Ret, not equal to -1. Have I ever tried Ghost TTY? No, I haven't. That's just another terminal emulator, right? Let's look it up. Why not? Ghost TTY. Yeah, it's a terminal emulator. I'm really happy with Alacrity, and I don't really have any reason to switch. Like, honestly, the biggest thing I like about Alacrity is that it has very few features, and even the built-in features, like it's got like some thing for like keyboard navigation is pretty like I don't use those features, and I actually have a lot of them disabled, just because they're not particularly useful for me. But yeah, so I forget that we can do assert not equals. That's fine. Ret is, oh, there's a semicolon there. So assert not equal. Great. Yeah, the font, yeah, Alacrity does a great job with rendering and everything. This is, what's the font called? It's called Eosevka. It's the font that like Soding, the streamer uses. I saw it once and was like, I like that font, and so I took it. Okay. Yeah, so I think our mmap is done here. Now let's call it. So we still need to open the file, but then we can say let file is mmap file. And so our previous time was 62 milliseconds. Or 62 milliseconds, I wish. Our previous time was 62 seconds. So let's see what we get now. And we can go ahead and remove this warning. And since the slice is still buff read, we can still use this lines function and see how this improves it. Yeah, I don't remember if he actually ever mentioned that this is his font, or if it's or if I just saw it in like I looked at one of his dot files or something. But yeah, I like this font. I used to use a font called Anonymous Pro, and I was like, I would die on that hill and refuse to use anything else. And then suddenly one day I was just like, no, I can't use this anymore. Guess it works well in Emacs too, lol. Yeah, I guess I've tried Emacs a few times. I just can't use it. But it works very well in Vim, which is more important to me. Okay, so that saved 4 seconds. Another thing that helps is y'all size to a reasonable line count for the stream. Yeah, I try to, but I do often forget. I kind of So I have this that I'm considering like setting up a script to like just automatically switch my line or the what's the word, the font size when I start streaming. I just need to like set up a decent script for it and then have it switch back when I'm done. And I think with OBS, which is what I'm using for streaming, I can have it run like arbitrary shell scripts so that it does that automatically, but I just haven't gotten around to setting that up. So I do just kind of manually zoom in right now. Yeah, that's the joke you're using. Yeah, I mean, I can use Emacs too. I'm cool like that. Except I'm really not, because I don't know how to use Emacs. So that's why I don't use Emacs. And plus NeoVim is just better. But yeah, so that saved us like 4 seconds, which is okay. We're still having to iterate individually over every single character though. So many streamers have a 30-inch stream and it sucks because it's down res. I'm also chilling on iPad mini right now. Yeah, that's exactly why I try to not do it. Because I have seen like streamers or YouTube videos or something where the font size is so tiny, and then watching that on like a phone or a tablet or something is just awful. Yeah, so let's replace this like lines check. Let's basically get rid of all of our string and UTF-8 parsing, because right now we still have to iterate over every single character. I mean, I guess we're going to iterate over every character, but we're going to have to do a lot less work if we're using bytes instead of chars. So first of all, we can just split by, so file here is a slice, so we can split where B is a new line to get to our individual lines. We no longer have to unwrap here. And then here we can split once by a byte. Oh wait, line is a slice. Oh, wait, split once is unstable still? I thought it got stabilized. That's fine. I think it's okay to use nightly. Rust up, override, set nightly. And then here we can say feature unstable, or I guess slice split once. And let me restart so that Rust Analyzer stops screaming. And yes, I do mean a byte literal. Thank you. Split once requires a closure. Parse is going to be annoying because this is now a slice. For now, let's just use standard stir from UTF-8. Unchecked. Standard stir. And we can do this because we know that the strings are supposed to be UTF-8 valid. Safety. Strings, or I guess station names are UTF-8 valid by README. Basically, README says so. Parse. Oh, no, this needs to go here. Like that. Then we can parse that string and then do this. This does still require that we do a UTF-8 unchecked, so it might be better to write our own custom parser, but we'll see about that. Station can now just be a vec of U8. And this is going to be 2 vec. And then station here is going to be standard. Actually, let's just do let station. Is going to be what? So station is standard stir from UTF-8 station. And we can do unchecked here as well. Unchecked. And I guess this isn't even a station name. This is a temperature. In fact, I don't even care about the safety comments. We're going to be doing a bunch of questionable unsafety things anyways, so it's fine. Great. You need to be a reference. And you are expecting semicolon. Wonderful. So now if we run this, it's gonna take a minute to build because it has to build nightly, but then we can run again, and we're trying to beat 58 seconds. So let's see what replacing strings with like bytes ends up doing for us. Oh, and I probably should have been committing throughout because, like, good habits, but it's fine. We'll live. Okay, yeah, so 38 seconds. 38 versus the 58 from before. So that saved us 20 seconds, just removing the string parsing. So that's pretty good. UTF-8 is kind of costly, so I'm glad we were able to get rid of that. So we have station 2 vec here, which is kind of not great because it does require an allocation. But I think I have a mild concern that if we keep a just a reference to that slice, then we kind of invalidate this sequential, and so it might become a little bit inefficient. But let's do a quick check on that, I think, and then see if maybe we can notice any performance issues with this. So we're at 38-ish. If we run this again, so we're at 38.7 or 0.8 if we want to be super precise. Let's see, hopefully we get a little bit, or I would not be surprised if we get a little bit slower by doing this change. But I guess we will find out. No, so we're technically ever so slightly faster. That's a little bit surprising. Oh, but we got a panic. I didn't even realize that. Did we get a panic before? We got a panic before. Hold on. I did not notice that. What are we unwrapping? Unwrapping on line 88. So that's this guy. So it's a line that doesn't have a semicolon, which means it's probably an empty line. Let's do if line is empty, then we're gonna break. I think every line is terminated with a new line, so that would make sense. Which actually means, god damn it, let's undo this. And let's keep this as 2vec. And then this needs to be a reference. And let's actually run it properly. So maybe we didn't save 20 seconds. So we're trying to beat the 58 seconds. Yeah, 58.5 seconds from before. I suspect it'll still be faster, but probably not 20 seconds faster. But we're going to find out. Okay, yeah, so we still got basically the same amount of time. I don't think printing ends up taking all that much time, just because that happens once versus the other thing, which happens like a billion times. So I think we're cool there. Yeah, so let's go back to our just taking a reference and see what this ends up doing. That reference is unnecessary, but the compiler should probably just remove it, I think. Let's see, what does Clippy say? Which is immediately dereferenced by the compiler. Yeah, so the compiler just removes it. So we don't actually need to restart. Although we need to restart because of... Oh. Because of that. Wait. Why did it still take... Okay. Never mind. We're just gonna run it again. We're trying to, like, not account for the time that the compiler takes, even though it's, like, 160 milliseconds. And it doesn't ultimately matter on our 39 seconds, but still want to limit the noise that we get. Okay, so yeah, that saves about 4 seconds. That's not too bad. Yeah, I guess we can leave it like that. That doesn't seem to be the end of the world. Now that we've done that, let's do a perf record cargo R release. And just let it run for a few seconds. And then perf report -g. Oh, I forgot to perf record call graph dwarf. And we'll let it run for a few seconds. And then we can do perf report -g. So now we come in here. We can look at the main. There's a lot of stuff that's not in here. Oh, you know what? Yeah, we need to do profile, release, debug is true. What else can we do? I guess that's probably fine. I didn't really want to do that. What are you doing, perf? Cargo R release. And then now we run it. That way we don't include the time that it takes to actually build the software. Or build the application. And then we can kill it. And perf report. And then hopefully now we have a few more symbols. Ooh, not backspace. There we go. So parsing our F64s takes a long amount of time. It is interesting because we are broken out here. Which kind of makes me think that maybe our like stack isn't being preserved. Oh, there's a Rust thing. What is it? Let's do makedir.cargo. Force frame pointers Rust. I forget how to do that. Cogen options. Force frame. Yeah, force dash frame dash pointers. Where does this go? I don't remember how to do the cargo config. Cargo config. Is it just like build? I think it might just be build. Rust, or force frame pointers is true. Cargo, let's just build it. Unused key, so no, that's not correct. Wait, do you have to pass it through -c? You might have to do that. Rust flags, -c, force frame pointers is true. Or wait, so it says, yes, on or true. Let's do true, because that sounds cooler. Okay, now if we do perf record, and then perf report, I think we should have better stack frames. A little bit. Yeah, okay, this is much better. Can I scroll down? That'd be cool. Okay. So we have actually getting an entry takes time. Shocking. Parsing F64s takes a while. Takes 13 seconds. That's not insignificant. Or 13%. Splitting. So actually looping over. It's unclear which split this is. Or no, okay, wait. We only split. Let's go look at the code. let's go look at the code. No, let's go. What am I doing? Let's go look at the code. There we go. We only split like generically on new lines, and then we split once on the other one. So we actually do have a difference there. So split once is taking 8%, but split like normally is taking 11%. So that's not insignificant. So we also have parsing F64s. What else? So add a sign is taking time. So min and max are actually, that's taking a significant, or it's taking more time than I would have expected. Okay, wait, so also we have unwrap is taking 73% of the time. So, or not 73%, 0.73%, very big difference there. So I think between this and the actual parsing of F64s, I mean, that's taking almost 15%. So let's get rid of the F64 parsing. Actually, before we do that, let's just commit what we have. So git ignore measurements.txt and all perf stuff. How long do we take? Let's do a quick timing. That way we don't actually have to, by doing the build before time, we don't actually worry about just the build time being included in the time. Not that it really matters if it takes 20 milliseconds, but whatever. So I think this should be taking about 35 seconds is what we're measuring. 37, okay. So let's do git commit 37.5. Not that is a horrible commit message, but it's fine. It doesn't really matter. Okay, so first of all, temp is we parse it into a string and then we parse that string. Let's create a function. Parse temp, which takes in the bytes as a slice, and it returns. Okay, so here's the thing. We don't actually need to use floats because we know that, like, we don't have arbitrary precision to deal with. We just know that it's like we know that it's between minus 99.9 and positive 99.9, and we know that we only ever get a single decimal point, so we can just use I16. Like there's no reason we can't just use integers instead. Printing is gonna have to change a little bit, but like for now this is fine. So parse temp, what does it do? So, I mean, for now, let's just say let mute out is 0. Then for let's do this. Let's iterate for b in bytes. Match b. So if we get a negative, then we're going to do something. If we get a digit, then we're going to do something else. And then if we get a dot, then we're just going to ignore it. And then we're going to return out. So non-exhaustive patterns. Yeah, everything else is unreachable. So if we get a digit, that one's pretty easy. We're going to say out times equals 10, and then out plus equals b minus 0, and then it's going to be an I16 from. If we get a minus, we need to negate out, which doesn't work really if we're going to be iterating from left to right. And then iterating from right to left is a little bit painful because then we have to deal with this a little bit differently. Let's see. Can I guess we can do rev, and then we can say, and then I guess we could just take the index. And then here we say times 10 times I. And then here we say out times equals -1. Right, so now we're parsing from right to left. And if we get, like, say we get minus 43.2, then we get our 2. I is 0, so we just say 2. Then the next stage we get a dot, which we don't care about. Oh no, that's not gonna work. I needs to be independent because we need to only increase it if we get a dot. Or if we get a digit. There. So now if we get back to our 43.2, minus 43.2, we're on 2, and I is 0. Then we're on the dot, we skip it. Then we're on 3, I is now 1. So we get 30. We add that, so now we got 32. Then we're at 4, the I is now 2, and we're good. Okay. Now this is technically a little bit weird for minus 0.0, but I don't think that's going to be a possible value. Technically it's possible in floating point, or in like IEEE 754, but it doesn't really matter. So now here we're going to say parse temp. Temp takes the bytes, takes the temp. And then we can remove this dot parse. Actually, we can remove all of that because it can't fail. And then now we need to change the station. Or the stats to be I16s. And then the sum should probably be a much bigger number. Let's do an I64, I think is what we're going to need to do for that. This is going to return... yeah, I guess this can return an I64. Or I16 should be fine here. So this is going to be I64. Then this is going to be an I16. Can I replace this with a from? I cannot. Oh wait, sum is already I64. Okay, then this is going to be I16 max, I16 min. Expected I16 found F64. Right, so this is going to be an I16 as I64. Great, so now everything should be working pretty much the same. We're trying to beat 37.5. The printing is going to be a little bit wrong, but that's okay. We can fix that. I just want to see if this has any like significant impact on the performance. I mean, we should be expecting about 10% faster, so maybe like 34-ish seconds. $32. So that's quite a bit better actually. And we should still be getting roughly the correct thing. So 13.0. That's very wrong. Wait, what? You know, I didn't actually check. What is our diff? Our diff is just that. So if I get stash and then we run it, I didn't actually check that the output was correct. So let's do that. Okay, 34.7. Oh yeah, we're still printing incorrectly. But that's fine. So 34.7 minus 34.7, 17.9, and the 68.8. So all of that is correct. So somehow in our changes, we managed to fuck that up. So let's go see what we can figure out. So if we run this again, we got minus 13 instead of the minus 33, or, yeah, minus 34, which, I mean, makes me think that this is probably wrong. The parsing is probably wrong. Let's, instead of doing it, let's try to, instead of trying to do this like fancy, let's do let mute negate is bytes 0 is a minus. And then if we have, if negate, or I guess we can say what u size from negate. File's been changed. That's because we stashed, but I don't think it should matter. That's fine. Into iter. So basically, if we are negating, meaning we have a negative sign, then we're just going to skip the first thing, which means that we're skipping that minus. And then out times if negate -1 else 1. I don't know if this gets inlined, actually. I would expect this to become... You know what? I don't know. And so let's just do I16 from negate times 2 minus 1 gets us 1 to -1. No, that gets us 0 to -1. I want minus -2 plus 1, which says if we get 0, or so if we get false, I16 from gets a 0 times -2 plus 1 is 1. True says if we get 1 times -2 plus 1 gets us, so 1 times -2 is -2, -1. So that does what we want. Cool. Yeah, that seems fine. And then now, theoretically, this might be a little more correct. And we're still trying to beat 37.3-ish. Okay, so we're at 30.62, and okay, so our numbers are even worse now. What the hell? Okay, let's do this. Test. I guess let's do config test. Mod test. Yeah, we're gonna write some tests for this. Test. Parse A is gonna be assert eq parse temp, which needs to be imported. I guess let's do superstar. So 42.1 should be equal to 421. Minus 42.1 should be equal to minus 421. 9 should be minus 9.1 should be minus 9.1. And then the positive should be positive. 0.1 should be 0, 1, or just 1. Cargo T. So we're immediately wrong. Okay. So literally the first line is wrong. That's cool. Where is that function? There. Parse time. So skip. This does what I want, right? Let's try to just comment this out. Yeah, so it still fails. You know what? Let's take like a 5-minute break before we start digging into this, and we'll be right back. And we're back. Okay, let's look at this function. What is it doing? Okay, so We iterate over the bytes. That makes sense. Let's just debug B. And then char from B. So 42.1. That seems reasonable. Let's also log out. 42. Oh. Okay. I'm just stupid. What are we trying to beat? 35.77? $37.32. I don't know where my number came up with, but let's see. I mean, I don't expect the performance to be any different from the last time we ran it, where we got 30-ish seconds. I just expect the numbers to be more correct. So 30.52, that sounds good. And then 34.7, which is correct. 34.7 minus 34.7. Yeah. 17.9, yeah. 68.8. Yeah. Okay. Okay, that seems cool. Now let's fix the printing. I guess we can leave this test in here because why not? And then we need to print print the thing. So let's create a function called print float, which is or it doesn't even return anything. It literally just prints the float, and it takes the number, which is an I16. Print as float, and we could like cast it into a float here. Actually, honestly, that would just work. Print. In fact, I don't even want to do that. I would want to do station as f64 divided by 10. That should just work. Or not, no, not station, sorry. Min, mean, and max. Like that should actually just work. So 30.5. I would expect it to go up just a touch because now we're actually doing floating point operations, but we only do them once at the end, and it's only 10,000, so it shouldn't even be that much. Only up to 10,000. I don't even think our input data has that much. Oh, and the other thing is this should be printing with :1. And we need to be explicit about this because even though we don't have enough data, there's still like a chance for like a rounding error, especially since we're using like 10. Though I don't actually see there's the other side of that where if we just have a round number, it doesn't print the .0. Okay, let's run this once more, and let's write the output to us.txt. And I just want to do a diff to make sure that everything is fine. Specifically because we have this condition here, which is that we need to round towards positive, and I don't know if we're doing that right now. In fact, I would say we're probably not doing that. We're rounding towards 0, I think, right now. So 31.93. That's a touch slower, but I suspect that's just noise. If we look at the us.txt, we do just have this one line. Cool. Let's grab this to dev rust a obrc or obrc. I don't know where I said a. And let's create a file called real.txt. Okay, much faster. And the real.txt is in basically the same form. And then if I do diff real, or actually let's do nvim-d real.txt and us.txt. Okay, so they are slightly different. And yeah, it's exactly that. So we're rounding towards 0 here. They're rounding towards positive infinity. This diff view is a little bit annoying. Is there a better way to do this? I don't think so. Let's just replace comma space with a new line. That's not what I meant to do. Comma space with a new line. And do that over here too. There. Now it's a little bit cleaner. Yeah, so specifically the mean, we need it to round towards positive infinity, which it's not doing right now. That's interesting. I don't know how to do that from an integer. Go away. So the real issue is not even in the printing. It is specifically in this, where is it? This mean function. We are, actually, I wonder, I mean, we can just use self.sum.as, or just as f64, divided by self.count as f64. We do this so rarely that I think it's okay to do floating point stuff in here. There's round, I think it's this. I think the default round does what we want. And then this can return the f64. And this doesn't need to do this anymore. And I think we need to do divide by 10 here. Cargo R, or let's do that. Cargo be this. Although, wait, no, it said if ties are even, then it rounds away from 0, which is not quite correct. Let's look at this. Round towards positive. Always rounds the greater to the, wait. Always rounds to the greater of the two nearest values. This is like ceiling at a given number of decimal places. I'm having a really hard time reading today. We're at 43 seconds. Why is it getting so slow? This is a bit more correct, I think, but it's still not correct. Wait, but the line is great. This might, no, it's not correct. Okay. Let's do our replace again. And let's see. Oh, wait, rounds to 0. We need to do it like that. Or not rounds to 0, rounds to integers. Or whole numbers. I think there's a distinction there with floating point, but whatever. It rounds to .0. And I think actually seal does what we want. Because we're doing this before we even yeah, we're doing this before we do the divide by 10. So I think seal, I think this is gonna be wrong again. Maybe. Let's try just running diff. New line at end of file. That, really? No new line, wait. Oh, wait, no, that's just saying, real.txt. Let's apply this. Us.txt, oop, dot. Let's apply this. And then let's grab the diff. There is no diff. Oh, wait, we don't print the new line at the end of the file. Or wait, do we? I'm so confused. There's no diff. Which means we're doing this correctly. So I'm going to just say we're fine. That being said, it does seem to be significantly slower. And I don't know if that's just because we're piping it into output. So let's just run this again. Our previous time to beat... sorry, I know bitrate's probably not great right now with all this text on the screen. Previous time to beat is... Or like the previous time was 31.9 seconds. So let's see if we get the same thing here. $42 seconds. So something has significantly slowed. And I wouldn't be surprised if it's this mean. Because now we're actually doing float stuff in here. I mean, we could do something... We don't have to do a floating point division here. If we do times 10, we take the count like this. Then we can say as F64. And then we can round it. Right, so we take the sum, which is like 5, some numbers. Then we multiply by 10. Then we divide by the count, which will give us like, I don't know, 43.93. And then we cast it to a float, which will do that. And then we need to divide by 10. Which does that, and then we round it, which does that, and then we divide by 10. Which might be slightly faster, because now we're not doing the same floating point division. I don't actually expect this to be faster, thinking about it, because we do still have to divide by float here. So let's see, 42.73 versus some different number. Okay, so it's slower. I think it's basically the same. No, it's definitely slower. Fuck. Okay, so this being an F64 is kind of bad. Actually, I think if we were to just replace this with like 0, or I don't know, like 69 to 420, because we have to be funny. If we do this, is it faster? Not really, which is kind of surprising. What? Oh, this is supposed to be F64. Let's do a cargo B, and then let's do a perf record again on this and see if see what is taking so much time, because we didn't really change anything. I guess we changed this. Which is interesting. Right, because our original went from the back forwards. Oh, I forgot I was supposed to stop that. This is gonna be a big perf report. Yeah. Perf report -G. That's fine. We have all of the data now. This guy. So Rusty entry is interesting. So entry is still taking some time. Parse temp is taking still 7.45%. And this add assign is still taking some time because of min, but not max. That's interesting. Can I annotate? I don't remember how to do this. Annotate current symbol, collapse locale chains. I thought it was A. That's what I just pressed. Oh, no samples. Because it is inlined. Yeah, that's potentially it. Okay. That's fine. Let's do that then. Let's inline never. Run this. This time we won't let it wait like a minute. Okay. Wow, this report is taking a long time. What? Okay, that was weird. You. Parse temp. Annotate. Great. H for key bindings. I want to show the source if possible. Source code US. Aha, beautiful. Okay, so there's a bunch of inline stuff in here. Can I scroll? I cannot. Page down. Yeah. Okay, so this is the parse temp function. And this is basically the assembly view with the source annotations. So yeah, this branch is obviously taken a bunch of times. It's a little unclear why this, why specific things take the time that they do. But yeah, I mean, obviously the branching is slow. That's just the way that things work. It is another interesting thing is that we know, actually, let's just close out all of this. we know that this dot 0 is always here. So we know that out is bytes at bytes.len -1 -0. Like that is a thing that we know, because we know that the temperature is always in the format of like an optional minus. Yeah, sure, we'll do it this way. So we basically have a couple of variants for the temperature. We've got 9.0. Yeah, 0.0. We'll just do 0 for all digits. 0 minus 0.0, 0, 0.0, and minus 0, 0.0. Those are the 4 options that we have. Right? So we know that the last digit is always going to be some number that we can parse out here as out. And then we know that the first digit is always going to be either a minus or a digit. Sorry. Yeah, the first byte is always going to be a minus or a digit. And so we don't actually care. Okay, let's also change this a little bit. So bytes from usize from negate onwards does the same thing. We need it by reference. And then we also know that we don't need the last 2. So we can say bytes.len -2. Which now means that this isn't possible. And we don't really need to match on this anymore. Maybe we do debug assert matches like that. Sure, it doesn't matter. And then this is fine. And now we just removed a bunch of the branching in here. So let's run it and see if we get any benefit here. What are we beating? We're beating 43 seconds. Like that's a large amount of time, but 43 seconds is what we're trying to beat. Let's see if we get that. Okay, so 39. What was our previous? I don't even remember. I forgot the number. 43. So that did save some time. I guess like at this point we're not branching anymore. Or we are still branching. Obviously we can't get around the branching, but at least now we're not branching as much. And I do say we can't get around the branching. I'm not sure that that's true. We can, so for negate, we can actually apply the negation here. So let's see. Basically, like it's if negate out equals negative out. And that, I mean, that's basically what we're doing before, but now we're doing it before the loop. I don't think it'll change anything. So 39.26. Oh wait, I'm recording right now. Actually, you know what? Let's do. Wait, was I recording when I did this? No. Okay. I want to do this. Again, we're beating 39.26. Maybe. While that's running, let's see if there's any other things that we can change in here. Oh, okay, so it did not improve at all. What did we change? Or no, wait, it got significantly worse. I guess now we are actually technically branching here. I think this. So I think the compiler wasn't able to improve that, unfortunately. But that's fine. I think this is going to be a little bit faster. It's going to be faster than the 43, but I don't think it's going to be faster than the 39 that we had before. So let's see. Is there anything else that immediately stands out in here? Nothing, or I guess nothing immediately stands out. But is there anything else that we can take out here? So we've already removed this dot zero. I guess we know that the third digit from the end is always a digit as well. And I think that the compiler can't really unroll this loop. 43.82. So this is just worse than this was. That's a bit surprising because it does basically the same thing. I think we'll probably go for about 30 more minutes and see what we can do today. And then after that, we might see if we do another stream on this. I do want to bring in something like SIMD to do some of the more like lookup aspects, or even just the C or libc memchar function to actually do like the looking for the semicolon and looking for the new line. Yeah, so that still took 43 seconds. That's surprising. We didn't really change anything else. Like this debug assert should go away. We can just remove that. I think that's fine. I think we are able to completely unroll this loop. So let's go ahead and do that, I guess. So out is this. Then we can also add bytes at bytes.len -2 or -3 minus b0 times 10. Right, so this will do this digit and this digit. And we know that those are both things that can be done. This iteration is basically between this and this right now. No. What is this? So this iteration, so from negate goes, so we still use the start here. I do wonder if that improved it. Let's just try it. Because now we're doing one less iteration in this loop, but we do still have the like the termination condition in the loop that we need to fix. And there's the obvious other way to immediately gain a bunch of speed, which is to like parallelize it. So bring in like, or like start doing threading. But the problem is once you do threading, it gets a lot harder to profile. So I want to basically hold off on doing that for as long as we can. Okay, so that's basically the same. And that's not terribly surprising because we do still have to do all of the same loop checking. We just only do it one fewer times. Yeah, but what can we do? So I have a thought, which is that for parsing temperature, we don't need to necessarily know where, so when we parse the temperature, we split the semicolon. And then we pass that in. Yeah, so then we pass that into this parse temp function. But we could, theoretically, if we've got foo semicolon x, y, z, or I guess 0, 0.0, minus 0, 0.0, we can walk from the right side. So we know that immediately these are always digit dot digit. And then we know here we either have a minus or a digit. Let's do pound for digit. We either have a minus or a digit. And then here we either have a minus or a semicolon. Like these are just known things. So if we pass in the entire line to parse temp, we could basically have parse temp do both the splitting and the parsing of the temperature, like at the same time. So I think that's something we can try to do. So station and temp are going to be returned from parse temp. And yeah, so basically this station is going to be the rest of the bytes. Before we do that though, I think I'm going to have it be just parse temp because we know that this split still works. And then we can figure out how to do the actual indexing in a bit. But yeah, so now we have these cases. And so you can see we either have a semicolon or a space, or semicolon or a dash, or a semicolon or a dash, or a semicolon or a digit. This is the three cases. So first three are parsed here. And then for this next line, we can basically say if bytes at bytes.len minus 4, or we can let's match on this. Match on this byte. So minus 4 is going to be 1, 2, 3, 4. So this line. If we get a digit, that's a lot of rows. Yes, 1 billion rows. If we get a digit, then we're going to parse it as a digit. Actually, this is a bit weird. So if we get a digit, we're going to say that. If we get a minus, we need to do something. Actually, no, we can't. Wait, can we get we can get a minus. Right, so we can't do this negation anymore. This like ahead of time negation. And then finally, if we get a semicolon, then we just return. Yeah, this is basically a loop at this point. Let's do this. Let's say let mute out equals this. Out plus equals this. Basically, we're just going to unroll this loop. So if we get a digit, we're going to say out plus equals that. If we get a minus, say out minus equals 1, or wait, no, times equals minus 1. No, out equals minus out. They do the same thing, and I suspect they compiled it the same thing, but I don't know, it's nicer to do whatever. It doesn't matter. Then we're going to return out. And then if on the next byte, so if we still go, then we're going to check for, so byte 5, 1, 2, 3, 4, 5. So this one, we can't get a digit, but if we get a minus, we're going to do minus. Actually, if we do a minus, then we're going to return minus out. Otherwise, we return out, and then we just return out. Actually, no, everything here is just going to return out. Like that. And yeah, we can do that. That's fine. Great. Yeah, this should work. If I do cargo T, it should still work. Attempt to subtract with overflow, minus 99. Right. Yeah, that's fair. No, it's not. We know for a fact that we have at least a semicolon here. We are wrong. What the hell? Why are you stuck on my screen? That was weird. We know, or I guess we've messed this up. Yeah. Okay, so we're still running that correctly. What time are we trying to beat? 43 seconds, I think. Yeah, 43.38. And theoretically, this should be faster, although I'm not so sure. Oh, 43 seconds. Okay, I feel like I'm just butting my head against the wall at this point. Like, this should just be quite a bit faster. Oh, we're still inline never. Okay, without inline never, are we faster than 43? Because this function should definitely be inlined. Okay, so we saved about half a second like this. I'm just thinking about it that there's also a couple of things that we can do here. So if we set link time optimization to fat, inlining should be a little bit better. I don't know how much like actually better it's going to be, but it technically should be a little bit. In the TOML, we should be able to add, what was it? It literally just escaped my mind, God. Fuck, I forget what it is. We'll come back to that. But yeah, this should help just a little bit. Oh, that's gonna drive me crazy. How did I forget the flag? I don't know. We'll come back to it. But this might help a touch. Although I don't really expect it to be. Oh yeah. Target CPU is native? No. Rust, native CPU. Basically, by default, it'll use, like so I'm building for x86-64 because that's what my computer is. But Oh yeah, we can also do cogen units 1, which might help a little bit. But my specific CPU, the specific one that I have in my computer, might be ever so or might have a couple of like specific instructions that will make it a little bit faster. And so we can try doing stuff like that. Yeah, so this Rust flags target CPU is native. Let's add that. I thought there was a cargo config for it, but I guess not. Okay, if we do this, it's gonna have to rebuild, which is fine. Oh, I'm already handling that stuff. Wait, unused. Oh, did I forget to? I did. That's fine. Okay, now this could be slightly faster. So we're beating 43 seconds. Or what was it? 42.5? Yeah, 42.5 seconds. Let's see if those couple of flags have improved anything. I don't think it'll be monumental, but it might be like half a second at most. Okay. So we were at what, 42.5? I kind of forgot the number already. Yeah, 42.5, and now we're at 41.4. So it saved about a second. That's not insignificant. Let's see, what other things does this have? Minimizing binary size. I don't care about that. One popular alternative is JE malloc. I don't want to do that. Also, that's a dependency, so we can't do that. And yeah, so changing allocators isn't really going to be reasonable. Yeah, that's fine. You can go away, you can go away, you can go away. You can go away. Let's do a flame graph because flame graphs are cool. See if it gives us any like useful insights. I don't really know that it will, but let's see. So flame, I guess. Ooh, that's really bright. And unfortunately, I don't think there's like a dark mode. Is that? Yeah, I can't do that here. Wait, actually, is there a dark mode? I think there was. Let's see, cargo, flame graph, dark mode. Really? Interesting. Okay, that's fine. That's fine. We'll just burn. Okay, so entry is obviously taking a large amount of time. So hashing itself is taking a long amount of time. So we can improve the hashing by using a different hasher, which I think is something we'll do. But I kind of want to improve some of the other things first. So splitting here. I don't know how well you guys can see this, but zooming in kind of breaks it. So splitting on the new line is taking a very large amount of time. Like you can see, yeah, see this is the problem. I can't really zoom in because it breaks the canvas. What if I zoom in and refresh? Does that work? No, it doesn't. But yeah, basically we're spending a lot of time just iterating. So let's commit what we have. So adds let's go to our git ignore. and add all of our text files. And we can remove measurements, I guess. And then we can remove the flame graph. SVG. Yeah, so let's look at our diff, just make sure everything here is fine. This is just switching to integers. Okay. F64 to I16. Okay. And then let's see what we can do about this split, this guy. So actually, wait, hold on. Before we do that, let's do this thing that I was talking about with the parse temp, where we return the station name from here as well. So this return, if we get a semicolon here, then we know that the station is bytes to bytes.len minus 4. So up to that semicolon, but not including it. By reference, of course. Then here, we have bytes.len, we have bytes up to bytes.len minus 6 because we have the dash. And then here we just have 5. And then down here we have station and temp being parsed as a single thing. And then now maybe we should be ever so slightly faster. So what are we trying to beat? We're trying to beat 41.44 seconds here. And ideally we also get the same output, but it's actually we can add that to our test here. So if we get ABC, then we should get ABC. Like that. Like that. Okay. And what time do we get here? We got 40 seconds. So that was how much time did that save? I forget the number. Was it 41.44? So that saved about a second and a half. That's not insignificant. And then if we cargo T, everything here is fine still, right? Yeah, okay. We get the same results that we expected, right? Yeah. Okay, that seems cool still. You know what's an interesting thing that just kind of popped in my head is we say stats dot min mod 10. And we can just do this. We don't actually need to make these floats ever. And it might be slightly faster. Mean, because of how we're doing it, still needs to be a float. But that is fine. This might be slightly faster. So we're beating 40 flat. Okay, saved exactly half a second. I'm kind of surprised that it's, oh, wait, fuck, that doesn't work. You can do an absolute. And I suspect abs is going to be a little bit better. What is unsigned abs? Computes the absolute value of self without any wrapping or panicking. That seems weird, but okay. I feel like that's like a very subtle thing that might occur in very rare circumstances. But maybe it'll be slightly faster. Maybe not. We're going to find out. Okay, it actually is a little bit faster. Or I guess we're doing the absolute value in general here. I suspect that in reality it's about the same and it's just noise, but it's fine. We'll leave it as is. One other thing that I don't know if it matters. I don't know what the buffering on standard IO looks like, but we can do standard out is standard IO std out lock. And then just write to standard out. And actually, really, we could do std out dot write this here. I don't know that this is actually any faster, but it's fine. And then we need to import write as well, obviously. And we can even unwrap unchecked. Unwrap unchecked. Because we're super unsafe people. Unsafe. Oh, we don't even really need to unwrap this. And now we don't even need to use unsafe. Because this basically can't fail. Technically it could if like standard out was closed or something, but it doesn't really matter. That's not going to happen. Let's see. I don't really know if this locking will do much, but it might do something. So we're 38.72. And I'm gonna forget that number, I bet. So that slowed it down. That's kind of surprising. Okay, that's fine. Another thing here is this sort unstable might be slightly faster if we just said let much stations and we used a B tree map. This might be slightly faster. We're going to see. So we're trying to beat 38.72. Interesting. I suspect it had no impact. Like I don't know that it excuse me. I don't know if it necessarily made it worse or if it made it like no different, but we're gonna see. I just brought back the VEC that we were doing before, and we'll see if this changes anything at all. While that's running, let's look at memchar. So memchar. So memchar is the function within the C standard library or within like libc for scanning some sort of memory range for a byte. It says a character because that's what they're called in C, but it's a byte, U8. This is interesting. The memchar function, a raw memchar function is similar to memchar, but it assumes that an instance of C lies somewhere in the memory area starting ahead. That's interesting. That doesn't really apply to us, I guess. So memchar is the same thing as dot, not necessarily dot split, but I think there's dot find or what is it? Position? No, okay, it's effectively iter.position. Except, okay, yeah, so our B tree map is slower. Except it returns a pointer to where that character is, and so we have to do a little bit of pointer arithmetic to make it work. However, the way that memchar works is that it uses, okay, great, double click does that. The way that memchar works is that it uses like SIMD and everything underneath the hood, under the hood, to be super fast. So we're gonna use it. Right, so we're gonna say, actually, let's commit what we've changed. What have we changed? Basically, parse temp returns, or handles semicolon split. And I guess we can remove that. That's not super useful. Okay. So yeah, let's replace the split. So how are we gonna do that? Let's do, let's replace this with let's just replace it with a loop. And then we're gonna say let line is, or okay, so before we do anything, let's declare the this is memmap, docs.rs libc. Let's declare the memchar function. In our own custom libc. Size C is not a thing. We have use size. That's fine. And then in here, so the current line is file. And we're going to hold on to a rest, which is going to start off as file. Then from here, we're going to say memchar, libc memchar. Did I accidentally report that? I did. Libc memchar. So the first thing is the pointer to the content, which is going to be rest. Rest is already a reference, so we just say as pointer. And then we need to turn it into the pointer, the void star, the void pointer. We also need safe, obviously. Then the character that we're looking for is new line. And then the n here is going to be the number of bytes that we know are in rest. So this one should be rest.len. So this is going to be the pointer. And actually, let's just do this in a large unsafe block because we're going to do multiple things. Rest pointer is this. You can convert you. Yeah, that's fine. All right, not even that. I want to do I32 from. Ooh. That. Okay. So now we have a pointer to the rest of the contents. We can then say rest is standard, or sorry, this pointer points to the new line. Let's call this even new line pointer. Then we're gonna say rest is, what is rest? So this is gonna be standard pointer from parts, from raw parts. It takes a pointer to the new line. We can add 1 because we can skip this new line. We don't actually want the rest to point to that first new line. And the metadata here is the length of the pointer, which is going to be rest, or the length of the slice. So it's just going to be rest.len minus nl pointer as usize minus 1 because of that new line. Oh, this is standard pointer. This needs to be slice. And then this also needs to be as star constituate. Can I do dot cast here? I don't know. I can. Beautiful. In fact, I can probably do dot cast here as well. I don't really know the benefits over dot cast, or of dot cast over just as. I think it's just more idiomatic to do this. So this gives us our line, or the rest of the buffer. But then we can get our line. So line here is going to be rest sliced until the NL pointer. Which is what? So it's going to be rest.asPointer. Wait, from a pointer range, can we create a slice? So we have from, yeah, so we can do pointer from pointer range, which is kind of nice because we can say rest as pointer dot range. How do you create a pointer range? Or I guess it's rest.asPointer dot NL pointer. And those are both going to need to be dot cast. To constituate. Or I guess this one's already a constituate. Oh, and this is a mute pointer, which is just wrong. But since C doesn't have a concept of mutability, it kind of needs to be. Let's see. So here is, do we have like a const? Cast const. Oh. Sure. Use of unstable library slice from pointer range. So slice from pointer range. Great. Expected value found macro line. Right. This is the line. And this needs to be mutable. And then here, if the line is empty, then we can return. This seems potentially fine. I feel like we're probably going to get a seg fault, but only one way to find out. No seg fault yet. I would expect the seg fault to be at the end of the file. So we're trying to beat 38.61 seconds though. So maybe we're going to be good. Actually, we can just 38.61. So we saved about a second, but we did get our seg fault. So the issue is if memchar doesn't find it, that means we're at the end of the file. If I open the man memchar again, pretty sure that'll return null, or null if character does not occur in the given memory area. So if null pointer, you know, there's an interesting aspect. Like I would assume raw memchar ends, or raw memchar will be slightly faster. And if we're already at the end, like basically if rest is empty, okay, let's try that. So if rest is empty, then we can break. Does that fix our seg fault? Because if it does, then we can use raw memchar. And we can see if it's slightly faster. So we're trying to beat 37.28, although I don't really expect it to actually beat it. I'm a little bit disappointed that, okay, so it doesn't fix our seg fault. I'm a little bit disappointed that this doesn't improve as much as I was hoping. But we'll have to see what that means. So if null pointer dot is empty, or is, or not null, but new line pointer is null, then we're just gonna array. I did say 30 minutes about 45 minutes ago, so maybe we'll give it like another 10. So that also didn't fix it. Interesting. Fuck it, let's GF2 cargo target release OBRC. Let's break on, I don't know if we can, I actually haven't used GDB with Rust at all yet, so I don't know if this is going to be actually, let's just run it. This might take closer to a minute. I don't know how much overhead GDB adds when running. Okay. So we definitely have an issue. If I look at the backtrace, line 115. So it's actually this memchar that's failing. That's surprising. Wonder if there's something wrong with this So our call to memchar is wrong. I mean, this is effectively just calling as, yeah. This is also just grab that pointer. Unsafe function memchar takes the pointer, takes the integer, takes the usize. So all of this feels correct. Does memchar do anything weird if the length is 0? It doesn't say anything weird about it. Let's do this. Let's create a secondary input. We can kill this. Measurements 2, or no, let's do head measurements 2 measurements 2.txt. Just so we have a very short input. And let's run it on that. Which will be almost instantaneous. But now we get our segfault a lot faster. So if I do gf2 on this guy and we run, or I guess we can do that. We can also now just say debug rest. Let's not do rest. Let's do standard stir from UTF-8. Just to see what the actual rest looks like. What? So it prints it once. Does it still segfault there? No, now it's segfaulting in the from UTF-8, which means that somehow we set rest to be an invalid thing. Rest is a slice from all parts. Okay, can I do rest dot like, is there a way to get to the end pointer? Yeah, because now we can do standard slice from pointer range up to this guy from this guy, which might be slightly better. I guess we have to do castcons.cast. Okay, that one actually worked. Yeah, that worked a lot better. So yeah, I think our math there was just slightly wrong. But now it should be better. Okay. So instead of doing this, can I do if rest.len is less than 3? The reason I'm doing rest.len is less than 3 rather than like is empty is because there's a case where we just end up with a new line. And we know that we always have at least 3 bytes at the end, so I think this is just fine. And let's try this on the actual data again. You will also notice it does take a little bit longer to compile. That's probably because we added CodeGen Units 1, which means that all code generations all code generation happens in a single thread, rather than splitting it out, which just means that it's better at like inlining functions and stuff. But it does take significantly longer to compile. Okay, 37.7 seconds. Interestingly, this is slower than what we had a while ago. Like this floating point conversion ended up costing quite a bit. Like if we could look at this, or not this guy, but this commit. What do we change? So the LTO fat shouldn't have changed anything really. I'm a bit confused as to why this has made it so much slower. Let's see. Let's do first of all, let's commit this change. Memchur for new line. And let's do a cargo. Let's do a perf report. Record call graph dwarf. And then let's perf report. Okay, so let's look at what else we have. So main. So obviously, looking up in the hash map is still taking quite a bit of time. Add a sign is taking a large amount of time. Let's. Oh fuck! It's inlined. Okay, let's uninline add a sign. I don't really know what in here would take so much time. But let's find out. Okay, this guy. Ooh. Wait, now it's taking like no time. Wait, did something happen? Oh, something happened. That's weird. Let's just record again. Okay, yeah, that's better. Okay, in here we have, yeah, add a sign. It takes significantly less time when we don't inline it. What is that about? But that's fine. Let's annotate. Let's have source. VP broadcast queue. I don't know what that is. VP broadcast queue. I don't know what that does. Load the integer data from source operand and broadcast to all elements of the destination operand. I don't know what that means, but okay. So that seems to be expensive. Oh, I guess that's probably for converting it into the i64 that we're doing. And then obviously hashing. I think hashing is going to be the next thing to tackle, but I think we'll do that on on the next stream. I do want to see if maybe there's a function here. I kind of doubt there's a way to add like a smaller. Yeah, I don't think there is. I mean, in reality, this can be like an i32. I think I don't see that the sum could be bigger than an i64 or bigger than an i32. But I don't really expect this to have much performance impact. So what is our time to beat, by the way? 37.7. Yeah, I mean, it made it worse, but I suspect that's just kind of like noise. Oh, we're also doing inline never still. Let's try that. While that's running, let's create a GitHub repo. OBRC. 1 billion row challenge implemented in Rust. Let's copy that. And we'll set up the repo. $36.92. That is faster than it was before. Yeah. Git remote add origin. This. Oh, but is it correct? So 17.9 is what we have there. 17.9 is correct. 7.4. 7.4. I mean, I think that looks correct. Let's diff that again. Oh. What? I think Tmux did something stupid. Yeah, Tmux does not like super long lines. That's fine. Let's do that again and diff those again. Okay, so they're the same, which means that we can do i32s. Cool. i16 to i32 for sum. Now let's do get remote, or we already have that. Now we can just push. Okay, cool. So the repo is available here. You big. Yeah, 1 billion roses, kind of big. But that, I think, is going to be it for today. So thank you, everybody, for coming. I might, honestly, depending on how I'm feeling, stream in another few hours. But I do need to definitely take a break. So I'll see you guys next time. Thanks for watching.